Assalamu alaikum wa rahmatullahi wa barakatuh. With you, Mr. Sharif Abbas from Rima International School. I'm a science coordinator, and today, inshallah, we'll explain a very important lesson for grade 6. It is Unit 4, Lesson 1, the atom. Okay, what do we know about the atom? The atom, it is a small thing. We know that we can see with our naked eyes. We need not even a normal microscope to see it. We need a powerful microscope like electron one to see a small parts of the atom. But first, what is the atom and who is the first one which speak about it? The first one which speak about the atom, it is a philosopher, Greek philosopher before 400 BC year. It is Democritus. Democritus, he thought that eventually end up of the particles that couldn't be cut, and he told it the atom, or atomos with Greek. Its Greek word mean not able to be divided. That's mean he think that the matters at our world, okay, we can divide it until we reach a small, very tiny substance. We can't divide it more than that, okay? And he called it atomos, and that is the source of our name today, is the atom. Okay, but another philosopher, Greek philosopher called Aristotle, he disagreed with Democritus, and he didn't think or didn't believe that there is a particles could make up all substance found in natural. Okay, now we know the atoms, and now we know a lot of things about it. But you must know the definition of the atom. The atom is the smallest, I will show you the definition here, is the smallest particle into which an element can be divided and still be the same element. Okay, so we have here some rules. It is the smallest particle into which, not smallest only, but it can't be divided, can be divided more than it, and it still has the same properties. Scientists now know more about the atoms because of the power microscopes, but you must know that it is very, very, very tiny things. Okay, as you must know that our body is composed from cells. Okay, the cell composed from atoms. Are you imagine that? So the cell is very, very small, and the cell composed from atoms which smaller than the cell a lot. Okay, let's go to another page here. Okay, now we will speak about the theory of the atom. What is the theory of the atom? The theory of the atom, all the old scientists, they only speak about the atom. They only speak imaginary, but they didn't make any experiment to know more about it. The first one who tried to make an experiment, it is our scientist John Dalton. Unlike the ideas of Democritus and Aristotle, John Dalton's theory was based on evidence from experiment type. Dalton theory, he gave us 4 things we must know. Number 1, all matter is made up of atoms. That's number 1. You must know it. That's number 1. All matter is made up of atoms. Number 2, atoms can be created or divided or destroyed. The atoms can't be created. I can't make like Harry Potter, abracadabra, and I bring a lot of atoms. That is not happen. And can't be divided. I can't cut it to halves, as example, or destroyed. I have an atom and then they gone. No, I can't make this. So that is rule number 2. The atoms can be created, divided, or destroyed. Number 3, all atoms of a certain elements are identical. So if I take a hydrogen from here, from Saudi Arabia, it is the same hydrogen at Egypt, same hydrogen at Syria, Jordan, the same thing. Okay, they are identical. Okay. Number 4, every substance is made up of atoms combined in a certain ways. Every substance is made up of atoms combined in certain ways. All of substance around us, it's composed from atoms, but different atoms in different ways combined together. And he gave us the atom like this, a small, wait, I will draw it for you. Oh, wait, I will choose this, not this. Yes, this. Okay. Like a sphere. Okay, like a sphere. Okay, without anything. Okay, there is nothing inside it. He saw that for the atom. That's John Dalton. This thing was at oh, I'm so sorry. Wait. At 1808, okay, that is the year of John Dalton. Okay. At 1897, we have another scientist. We call it John Thomson. Thomson experiment provided the evidence that there is a small particles inside the atom, okay, and these particles have a negative charge, okay, and he gave it the name of this, and he gives the name of these particles. He called it electrons. He called it what, guys? Electrons. So Thomson thought that the atom was a positive sphere, and the electrons, they are mixed through it, embedded through it. It's look like a cookies. Okay, the cookies, we have a cookies and the chocolate chips embedded inside it or above it. Okay, that is the same thing of the Thomson. Thomson said that yes, there is an atom, there is like a sphere, it's a positive, okay, and there is a negative electrons embedded on it. So we will draw it like this. He saw that. That was at 1897. Okay, after that, guys, we have another scientist. We call it Ernest Rutherford. Ernest Rutherford. That was at 1909 or 1909. Ernest Rutherford, he said that yes, we have a sphere, that is, the atom was a sphere, and there is electrons, but these electrons revolve around, or sorry, maybe we can say it, rotate, revolve. It's the best, because revolve, it is around another other thing, but rotates around itself. So we will choose revolve. Electrons revolve around a small thing. We call it nucleus. So he said that the atom composed from nucleus, that is at the middle of the atom, okay, and it have a positive charge. He said that has a positive charge, and the electrons move around it. It is not embedded, it is move around it. Okay, that is Rutherford at 1909. Okay, after a while we have Niels Bohr, and that's very important scientist. Bohr agreed that there is an electrons, negative electrons, it is revolve around the nucleus, okay, but he said that the electrons revolve around the nucleus at a certain energy level, as you see at the picture. He said that the electrons don't move anywhere, okay, no, they have a levels of energy, they move through it. They have a level of energy, they move through it, and we call this model Bohr's model. And it's very, very important, Bohr's model, because we will use it inshallah at the next lesson to distinguish the number of electrons and valence electrons. We will speak about these things inshallah later. Okay, So at 1913 or 1913, Bohr said there is a nucleus, yes. Inside this nucleus we have protons, okay, and neutrons, okay, and the electrons, it is surrounded the nucleus, okay, in a certain level. This level we call it the energy level, okay, and we found the electrons move through these levels, okay. But finally, guys, you must know that all of this theory, unfortunately, wrong about electrons, because now at the certain days, the modern atomic theory, okay, they said that they are electrons, yes, but they don't move through this they don't move through this this levels only. No, they can move at all this part. Look, I will draw it for you again, please wait. Okay, if we have here a level, energy level of electrons, okay, and we have here the nucleus. So here we have the nucleus, okay, okay. The electrons, we can't found it. I will change the color. We can't the scientists found that they can't calculate the speed of the electron and the position at the same time. So again, at the modern atomic theory, the scientist can't calculate the speed of electrons and it is Bismillah, the speed of the atoms and it is placed at the same time. Okay, so they make a theory and they call the theory, it is a cloud of atoms. They said cloud of electrons. They said that the electrons is composed of, from a cloud. We can find the electrons at any place surrounded the nucleus, okay, like this photo at the book here. Okay, so that is the theory of the atoms. After that, now we must know what really we found inside the atom. Guys, focus with me. It is very important part. It is very, very important part. Okay, now all of us know that the atoms composed from number one, nucleus. Nucleus here, I will draw it for you, but wait, let's just choose this. Okay, we have here a nucleus. Wait, guys, nucleus. Okay, and we have here as example, oh, it's very bad, sorry. Okay, that's good. So we have here a nucleus. That is the nucleus, and inside the nucleus we found two important things. Focus with me, guys. Inside the nucleus we found what? We found a positive, let's change this color. I'm sorry, I will change the color. Okay, we inside the nucleus, we found a positive particles. We call it protons. So the positive particles inside the nucleus, we call it what, guys? Protons. Proton. Okay, that is what, guys? That is the positive charge. Okay, and inside the nucleus we found another particles. These particles, we call it neutron. Wait, I will choose, okay, yellow. I hope it's appear for you. Good. Yellow particles, these yellow particles, we call it neutron. And this neutron, it have no charge. Okay, guys? So the proton, it's positive charge, and the neutron, no charge. Okay, and all of these things surrounded by particles, we call it electrons. We found it around the nucleus. That is electron. And this electron, it is negative charge. So again, inside the atom we have three kinds of particles. The first particle, it is electron. It have negative charge, okay, and it surrounded the nucleus. Okay, at the nucleus itself we found two kinds of particles: proton, which have a positive charge, and neutron, which have no charge. Okay. You must know that, guys. You must know that if you focus at my drawing, you will know that I draw three protons and three electrons. Okay, I will put here another neutron so you will know that. Okay. Three protons and three electrons. So if I ask you a question, what is the charge of the atom at the all? The atom at the all, it has no charge. Why? Because the number of positive protons equal the number of negative electrons. If we have 4 electrons, that means we have 4 protons. If we have 5 electrons, that means we have 5 protons, and etc. Okay, let's speak about the mass of proton and the mass of neutron. There is a lot of information here about the mass, but you must know that the mass of the proton, it's very, very, very small. It is negative 1.7 times 10 negative 24 gram. That's mean 17 after 24 0, as you see here. I'm sorry, guys. As you see here, that is the weight of the proton. It's very, very small. So the scientist said we will give the proton, we will give the atomic mass, the proton's atomic mass unit, we call it U. This mass of proton, it's about 1 U. So when we said 1 U, 1 mass, that's mean 1.7 negative 1.7. Okay, 1.7 negative 1.7 times 10 power of negative 24. Okay, that's mean 1 U. Okay, that's protons. What about neutrons? Neutrons, it is very, very the mass of neutrons, it is regular about 1. Okay, it is more than proton a little, but we will consider it 1. Okay, what about electron, guys? If we speak about electrons, electrons have a very, very, very small weight. Okay, so that's mean if we have one proton at mass, it's equal 1000 at 800 electrons. 1800 electrons. So the electrons, it is very, very, very small. Again, so we can consider that the mass of protons, positive 1. Okay, we'll choose plus. The mass of proton, it is positive 1. The mass of neutron, it is no charge 1. The mass of electron, it is 0, because very small, so we will not consider the mass of electron inside our calculation. Okay, shabab? It's very important, and this compare is very important for us. This compare between, I don't know why it's look like this, but it's okay. Okay, let's compare between a proton and neutron and electron. They speak first about location. Where is the proton? We found the proton inside the nucleus. That's number 1. What about neutron? Neutron, we found it inside the nucleus. Okay, what about electron? The electron, we found it at electron cloud, which surrounded the nucleus. Okay, let's speak about the electric charge. Oh wow, we know it. The charge of proton, it's positive 1. The charge of neutron, it is neutral, no charge, okay? And the charge of electron, it is negative 1. What about the mass? We can say that the mass of proton slightly less massive than a neutron, or we can put positive 1. Okay, or 1, yani it's okay. And what about the mass of neutron? Always, if you put 1, it's right. And the mass of electron, it's almost 0. Okay, let's speak about a very important thing. Another very important thing. Okay. How can we describe atoms? We have, if we speak about the atomic periodic table, the periodic table composed from a lot of numbers. I will show you after a while the numbers of periodic table, and inshallah at next lesson we will speak about the periodic table and we will know a lot of things about it. But first, I must tell you thing. At every atom you will find 2 number. At every atom of any element you will find 2 number. As example, I will take for you Na. Na, it is for sodium. Okay, we will find 2 numbers at sodium, 11 and 23. What is the meaning of these numbers? Focus with me, guys. The small number, it is always refer to something we call it atomic number. Okay, and the big number, it is always referred to something we call it mass. Mass number. Again, so the small number always, it is atomic number. If it's up or down, it is atomic number. The small number, it is atomic number. The mass number, it is what, guys? It is big number. Okay, so we have 2 kinds of numbers. We found it as the symbol of any element. That's the example. Sodium is an example. We will take another example like hydrogen. We found it, it is 1 and 1. As example, helium, He, it will be 2 and 2. 2 and 4. 2 and 4. Okay. The small number, it is referred to atomic number. And the big number, it's referred to what, guys? Mass number. Okay. What these numbers mean? What is the atomic number? Or what is a mass number? I will tell you now. Let's go to another page. We will take sodium as example, Na. Here I will put 11, and down I will put 23. I change the colors so you can know that there's a small number and big number. Okay, if I ask you, what is the atomic number? Of course, you will tell me the atomic number, Mr. Here, it is 11. That's right. The atomic number, it is referred to the number of protons. The number of what, guys? Number of protons. So, if I ask you now, what is the number of protons? You will tell me, Mr. Of course, it's 11 because atomic number here, it's 11. Okay, and we take from while that is the number of protons, it is the same number of electrons. Again, the number of protons is the same number of electrons. So, the protons atomic number 11, the number of protons will be 11, and the number of electrons will be also 11. Okay, guys? So, the protons now 11, okay, and electron 11. Okay, good. That's very good. Okay. What about the mass number? The mass number here it will be 23 because it is the biggest number. Okay. What is the mass number referred to? The mass number, it's referred to the number of, focus with me, number of protons plus the number of nucleus. Oh, 1 minute. That's mean it is everything inside the nucleus. Yes, the mass number, it's everything inside the nucleus. Why, Mr.? Why we consider the mass, it's only everything inside the nucleus? Because if you focus with me, you will know that we don't consider the weight of the electrons because it's very, very, very small. So we take only the weight of protons and weight of neutrons. Okay, so the big number, it's referred to what, guys? It referred to number of protons. Okay, I will show you here as a book. The total number of protons and neutrons. The total number of protons and neutrons. Okay, that's very good. So, if I give you a symbol for any atom like this, sodium, and I give you two numbers, and I ask you what's the atomic number, you will choose the smallest one. What is the number of protons? It's the same, the smallest one. What's the number of electrons? It's the same, the smallest one. Okay, what is the mass number? Here, if I ask you about the mass number, it is the biggest number. Okay, what about the neutron? If I ask you what is the number of neutrons? Here, neutrons, guys, equal the big number 23, which the mass number, minus the number of protons, which 11. That's mean 12. The number of neutrons, 12. So if I ask you what is the number of neutrons, you must subtract subtract what? Subtract the big number from the small number from the big number. 23 minus 11. We will subtract both of them, okay, to get the neutrons. Subtract both of them to get the neutrons. Okay, I will give you another example. Like okay, magnesium as example. Magnesium, it is 1225, I think. I don't remember, but it's 1225. What is the atomic number? If I ask you about the atomic number, atomic number, it will be the small number 12. Okay, number of protons, also it will be 12. Electrons, the same, it will be 12. طيب mass number, the big number, it will be 25. The neutron, we will subtract 25 minus 12, it will be 13. That's the number of neutrons. Okay guys, I hope you understand this lesson. Thank you for listening, and see you inshallah next lesson. Thank you and goodbye.